Good afternoon and welcome everyone to this latest webinar from the CQI. We are delighted to welcome back quality management and training for another of these webinars. Today we're going to be discussing root cause analysis. Unsurprisingly, this has proved a very popular topic with our members. So we're looking forward to a really interesting presentation, as we've seen from QMT in the past, and then hopefully a lively Q&A session at the end. This webinar is being recorded and will be made available to all CQI members and ERCA auditors in the members area of our website. The slides will also be made available as a PDF after the presentation. And after the presentation, please also complete the feedback survey, which will follow. This is really a vital part of making sure that we improve the products and services that we're offering you, our members. Throughout today's presentation, please feel free to post your questions using the question panel on the GoToWebinar control panel. I and Jeff will go through those questions at the end of the webinar, going through as many as time will permit. You haven't come here to talk, listen to me speak, so with no further ado, I'd like to introduce from QMT John Dedman and Jeff Fawley. Those of you who've been on our webinars before will recognise both gentlemen. John has an MSc in Quality Management and Statistics. He's a Fellow of the CQI and a Senior Member of the American Society of Quality, a Certified Quality Engineer and a Certified Six Sigma Black Belt. He's delivered training and consultancy services to a large number of organisations ranging from SMEs to large multinational groups. He's also co-author with Jeff Fawley of the book Quality Management Six Sigma. And we're delighted to have welcomed John to a number of CQI webinars in recent months. Jeff Fawley is CEO of QMT Limited and author of numerous books on quality assurance, including the Quality Management Series and Quality Manager for several large international organisations. To talk to you further on the subject of root cause analysis, I'm very pleased to hand over to John and to Jeff. Thank you.
Thanks, Alex. That's really good. Thank you. So quality management and training have been around since 84, supporting CQI and ERCA training courses and textbooks based on their syllabus, together with open courses and quality assurance support as well. Hopefully there'll be one or two of our CQI students that are doing our course on the call today. Would be quite nice. The slide that you can see in front of you at the moment is as an introduction to root cause analysis, so what we're basing this course on. So it's just to say that the course is based on the CQI Foundation and Practitioner Introduction to Problem Solving and Managing Problem Solving syllabuses. So those syllabuses are the basis of the distance learning courses that you can also see in the slide there. There are some links as well. Hopefully, if you click on any of those links, the top two will take you off to CQI, and you can see the syllabus associated with those courses. And underneath that, there are some links to both the distance learning courses that support that syllabus and some open courses on root cause analysis. So if you wanted to find out additional information, you'll get it all from there. And with that, let's do it, John.
Okay, thank you, Jeff and Alex, and welcome everyone to this webinar. I'd like to explain before we start that I've been involved in quality management activities for many years, and root cause analysis, problem solving, improvement has been a very key part of that. And what I'd like to present in this webinar today are some of the key learning points that I've acquired over many years, and hopefully that will be useful to you, the listeners. The objectives of the webinar. First of all, we'll be looking at the key phases of root cause analysis, or RCA. We'll be looking at some useful tools and techniques. We'll be looking at how to ensure that a concern is addressed effectively. how to manage RCA activities, and how to take RCA forward, the next step. What is RCA? It comprises a set of principles, tools and techniques which assist an organisation to effectively address concerns and opportunities for improvement. It's applicable to manufacturing and non-manufacturing processes. It's utilised by a broad range of organisations and industry sectors, so it's very widely transferable. Why use RCA? When a process or activity does not meet requirements or expectations, there are likely to be effects, some of which may include loss of customer satisfaction and confidence, safety issues, non-compliance with statutory and regulatory requirements, disruption to business activities, and a cost, often a large cost, to resolve the problem, warranty claims, internal cost, etc. What should be done to address concerns? Well, the best time to deal with a problem is before it happens. The aim is to design quality into products and processes so that we avoid issues later on. And the panel that you can see on the screen at the moment shows a number of activities which many organisations use to try to avoid problems later on. These are things that are done at the design and planning stage, and actually root cause analysis and problem solving are often used at this early stage, and hopefully we avoid problems later on. However, if a concern does occur, it may need to be addressed by a formal problem solving activity. And it's important to recognise that underlying each problem is a cause. An important goal when problem solving is to identify the root cause and either eliminate it or control it to prevent the problem happening again. So that is a really key thing for the team to focus on. In terms of RCA, it's convenient to describe it in 4 phases: problem identification, problem description, cause analysis, and solution development. However, these phases are often incorporated within problem solving and improvement methodologies, such as 8D, 8 discipline, DMAIC, Define-Measure-Analyse-Improve-Control, and PDCA, Plan, Do, Check, Act. But in fact, the 4 phases can be utilised as they are. The scope of RCA, well, it applies to a wide range of concerns: internal and external concerns, products and services, all types of business processes, quality system audit findings, internal audits, external audits, simple and difficult problems. So it has a very wide scope of application. Let's have a look now at each of the 4 phases in turn, starting with phase 1, problem identification. When a concern is identified, a customer, who may be internal or external, are quite likely to report the issue as a symptom, something that they've experienced that suggests that something is wrong. It's important that the RCA team verify that symptom. The customer may not be able to describe it in technical terms. In this example, I've used the example of abnormal noise from a product that has alerted the customer to a likely issue. The RCA team will need to try to describe that concern in their technical terms and determine what facts are already known. Hopefully there will be something, if not, they will have to be determined. But very often some facts are known, and in this example, the team have been able to identify the direct or first level cause, which is that an item is incorrectly located. Now that will be established as a fact. The team will have examined the product and they will know that that's a fact. So that's a good start. However, the team will now ask the next level of question: do we know why this item was incorrectly located? And in this case, the answer is no. It's too early. It will need to be that will need to be determined by further investigation. So this is the start of the RCA activity. It's the start of the drill down to the root cause. It is very important that the symptom and concern are fully understood before this process continues. The Toyota production system have made some very key contributions to problem-solving activities, some of which you can see on the screen at the moment. Gemba means real place, where the activity happens. Genbutsu means the actual thing, the problem. Genjitsu means reality, emphasizes the importance of facts. Within Toyota, Genshi Genbutsu is a very key principle, and it simply means go and see for yourself. It's prompting the problem-solving team to collect data and facts at the actual site, which might be the work area, it might be the customer's environment. And it's not just a case of looking, this involves observing and understanding the context, understanding the flow of information, materials, work tasks as appropriate. The above terms are often summarised simply as Gemba. Go to Gemba. The aim is to obtain first-hand information to capture the voice of the customer, and this can assist the team with their investigation. There are triggering conditions which some organisations apply to RCA. It might not be necessary to carry out a formal RCA activity for every concern or issue that's identified. So I'm going to present on this slide some of the triggering conditions which I'm aware that some organisations use, which I think may be quite useful. First of all, when a concern is identified, the organisation should determine its significance, its scale, its priority, and hence the approach to dealing with the issue. So it goes through a kind of filtering activity. A few examples of triggering conditions are shown on the screen now. Is the reported symptom confirmed? Do we agree that yes, there is an issue that needs to be resolved? And what is the impact on safety, the external customer, our organisation, the environment? How serious is this concern? Is a formal RCA activity required by a customer, or perhaps an audit requirement? Often that is the case. Does our organisation fully understand the issue? If not, then we're going to need to utilise the team approach and possibly some tools and techniques. Is this a repeat concern? That would obviously be bad news because it implies that the previous activity wasn't fully successful. If a formal RCA activity is required, then it's usually carried out utilising a team approach and it's documented. Okay. Immediate action is very often needed. The aim is to protect the customer from the effects of a concern until a permanent corrective action has been implemented. It's necessary to determine the need for a temporary countermeasure, containment of non-conforming or suspect process outputs, sorting of process outputs at various locations, wherever they may be, to determine whether they are good or bad, and identification and recording of the number of good and bad items. And that can be very useful to the team because it provides them with additional information, and that can help them to scope the problem in more detail. A tool that is very useful to use right from the start of an RCA activity is a very simple checklist known as the 5 W's and the 2 H's. What, who, where, when, why, how many. This prompts the team to recognise and capture any facts which are already known. There might not be much, but anything is a good start, and any gaps can be filled in as the team pursue their investigation and acquire more information. Very often there will be 1 or 2 facts at least which get the team started. So that's very useful, but it has to be facts. Also, with the 5 W's analysis, the team will consider not only what is the issue, who is affected, where has the issue been seen, they will also consider in many cases the non-event. Have any customers not experienced this issue? Has the issue not been seen in some places? When does it occur? When does it not occur? The non-event is also useful information. Let's have a look now at phase 2, problem description. This is where the problem is clarified in more detail by obtaining additional information as necessary. For example, the 5 W's and 2 H's may be expanded. The team will consider what should be happening as defined by a formal requirement, specification, standard, etc., and what is actually happening according to our data collection and observation. And these must be facts, and any difference between these two is going to be very relevant to the problem-solving activity. A Pareto chart is a useful tool which might be used at this phase to enable broad issues to be broken down and prioritised. For example, if an organisation wishes to reduce the number of customer complaints, it would be helpful to understand the nature of the complaints and their frequency of occurrence or cost, etc. And I'm going to illustrate that on the next slide. Here we have a Pareto chart for customer complaints. It's simply a bar chart. Each bar represents, in this example, a product or a service provided by the organisation. But the bar chart is rank ordered. The tallest bar is the first one on the left. And in this particular chart, the height of each bar is the frequency of occurrence. But some other metrics, such as cost, is likely to be used as well, or as an alternative. However, this is a very broad problem. Customer complaints, it's very general. Cause analysis will be more effective if it's specific. So the team are likely now to focus on a particular area, to break a big problem down into smaller pieces for resolution. And in this example, I've shown a second Pareto chart, which describes the type of complaints for product or service D. So we can create a hierarchy of Pareto charts which enable the team to be more focused, and that becomes more useful. Also, a process flow diagram is likely to be used at phase 2, particularly if there are a number of process steps or activities involved. And this helps the team to determine the most likely point of cause in the process. The error or defect may have appeared downstream or even external to the organisation, but it's quite likely that the point of cause is upstream, and the team will be able to use their knowledge to determine the most likely place where the cause could have originated. And then, of course, they will go to Gemba. This brings us on to phase 3, cause analysis. Once sufficient information has been collected, when the situation has been grasped, the team will be in a position to start analysing possible causes and determining root causes. And this leads us into a definition of root cause. It can be described as the verified or proven underlying source of the problem, the cause which triggers a failure, the place in the chain of cause and effect where action could be taken to prevent recurrence of the problem. A root cause may be a drill down from a verified direct cause. Often it is, and it may be quite remote or distant from the direct cause. However, although this is a fairly general or typical definition, really there's more detail that the team need to be aware of, because there isn't simply one root cause. There are different types of root causes, and there can be more than one root cause that contributes to the problem. On the next slide, I'm going to illustrate now 3 likely drill down paths. First of all, we have the root cause relevant to the occurrence of the problem. This is the one that teams are most likely to focus on. Why did we have this problem? We want to drill down and find out why it happened. However, often there will be a second drill down path for the escape point. The team should consider, why did the issue reach the customer? It was bad enough that it occurred, but why didn't we find it before we released it downstream or released it to the customer? If we have checkpoints that are already planned into the process, these might be review stages or sign-off stages, or they could be physical inspection and test activities, or perhaps we don't have any at all. But either way, somehow the issue escaped, it got past those checkpoints, reached the customer. So we need to address that as well. However, there is an even broader drill down path, the systemic root cause. The team will then consider going beyond the current problem solving activity. They will consider, why did our planning fail? Why did our planning and validation activities not predict these risks, these problems? Why didn't we address them earlier? So there is a much broader drill down path which can result in ideally continual improvements of planning and systems for future products and services. A fishbone chart, which actually has 3 names, is a very useful tool for root cause analysis. It's also known as an Ishikawa diagram or cause and effect chart. It's typically utilised in the form of a large worksheet or possibly a whiteboard, which the team use to study the concern. The concern is normally described on the right-hand side of the worksheet, and often 5 standard categories are used: environment, method, machines, material, and people. These are used to help the team determine potential causes. However, these categories can be modified. Additional categories relevant to the problem can be introduced, but the 5 standard categories are often a useful starting point. And when the team have populated the chart with sufficient potential causes, they will then pause and review the results. And again, it's about prioritisation. The team will aim to determine at least one and possibly more than one potential cause which they believe is very likely to lead to the concern. But what's the next step? The important step now is to verify or prove these potential causes. So this takes us on to verification. Before implementing corrective action, each potential cause should be proven to confirm, to give the team confidence that it actually does contribute to the problem. And a very simple table can be used for this. The potential causes are listed on the left-hand side. They may have been derived from a fishbone chart. They may be ideas that the team have from knowledge and experience. Either way, they need to be proven. So the team will determine what investigation is required to prove these causes. And then they need to follow that up, and the cause will either be proved or not. When a cause has been verified, one of the most important tools in RCA is expected to be utilised, and this is the 5 why drill down. This is considered pretty much mandatory. It's a key tool for problem solving. It's used to drill down, to dig deeper when a potential cause has been verified or proven. For each verified cause, a drill down should be used to determine if there is a lower level cause. The aim is to find out, why did the verified cause become active? A key output of the 5 whys is to identify the part of the root which can be directly addressed by a permanent corrective action. I'm going to illustrate now a simple example of the 5 whys. And I've kept this example very simple because there are some points that I'd like to explain. Suppose that the concern is that tea and coffee taste bad, perhaps in the kitchen area of a business organisation. The team will investigate this and ask the question, why do we have bad tea and coffee? The answer to this question has to be fact. Investigation is required. It's not about theories or ideas. Suppose that the team determine that the milk is stale. They've confirmed that, they've assessed the milk, they've determined that it's stale. This is likely to prompt an action which will involve replacing the stale milk with fresh milk. However, the effectiveness of this action needs to be considered. In this case, the action addresses the symptom. It doesn't prevent recurrence of the problem. The fresh milk could also become stale. The team will recognise this and they will continue to dig deeper. It's also worth noting that this is a direct cause, and a direct cause is often physical. It doesn't have to be, but often it is. The team will now ask the next level of question. Why is the milk stale? It has to be answered with a fact. They have to investigate and find out why. Supposing that they find that the milk is too old, it's past its expiry date. Okay, so why is it too old? Because it's been stored too long, perhaps in the refrigerator. Why has the milk been stored too long? Because there's no stock rotation, no stock control. And why is there no stock rotation or control? Because there is no system for storage. And the team will now realise, they will recognise that they've reached a rather different level of describing the cause, and this is likely to prompt an action to implement a system. The likelihood is that this action will be rather more effective. This should be a permanent fix which will prevent recurrence. This should be a proper permanent corrective action, and this is really the point that the team wanted to get to. This is what they would have visualized, they would have been looking for, the level of cause that they can address with a permanent action. A root cause can be physical, or in this case it's intangible, which is often the case. Many problems originate from a weakness in a procedure or a process. However, although the 5 is fairly simple in terms of the theory behind it, it does require good understanding by the team as to how it works. On the next 2 slides, I'd like to explain some guidelines for effective 5 whys. First of all, it might not require exactly 5 levels. More or less may be appropriate, but it is expected that there will be adequate investigation of the cause, which is why the number 5 appears in its title. It must involve facts, not theories. This conveys that investigation is required. Ideally, it will be carried out with visibility of the problem or the work area at Gemba. And you probably recall from the earlier slide that there are in fact 3 different drill down paths. Each of these require an individual 5 why. Why did the problem occur? Why did the error or defect reach the customer? Why did our planning systems fail to prevent this problem? Some practitioners refer to 15 why because there are in fact 3 times 5 drill down paths. It's important that the team focus on causes which the organisation can control. There may be factors that are beyond the control of the organisation, but the organisation should consider, how can we help ourselves? What can we do to help manage or improve the situation? It may be necessary to use a tree diagram for more complex cause and effect chains. Sometimes the why question can be answered with more than one answer. So this means that the 5 why branch out into a tree diagram. Moving on to, or continuing with the effective 5 whys guidelines, how do the team confirm that a root cause has been identified? It should be possible to answer yes to the following 2 key questions. For practical purposes, can this level of cause be considered to be the beginning of the chain of events, the failure mechanism that leads to the problem? The aim is to get as close as possible to the source, but the team have to recognise the feasibility, the practical constraints that might exist. If the cause is addressed at this level, will it prevent the problem from recurring? Fixing a root cause will prevent the direct cause and the problem from recurring. So this is really what the team are aiming to achieve as the outcome. This then takes us into phase 4, solution development. Having confirmed the root cause or causes, some sort of permanent action needs to be taken, or the problem is likely to recur again. When evaluating and selecting a permanent corrective action, the team should consider the following guidelines. The action should address the root cause of the issue. Often this will involve changing the relevant process, activity, design, etc., to eliminate or reduce the likelihood of errors, rather than simply reinstating some existing practice or system which clearly didn't work effectively. The action should address human error to the extent possible, where that's relevant. The use of error proofing is strongly emphasised within RCA, Poka-yoke principles, for example. The team should also consider the possibility of adverse effects, risk analysis. The corrective action may solve the current problem, but it might introduce a new problem, it might introduce a concern or a hazard. So the team need to consider that possibility. And other factors such as cost, degree of difficulty, time to implement, these may also need to be considered. However, most importantly, the action should prevent the problem from recurring. When a countermeasure has been implemented, a suitable validation period should be determined, i.e., how long the process will need to be monitored before the countermeasure can be declared effective and the RCA activity closed. Before and after measures of some sort are expected here, not necessarily in the form of data or charts, as I've illustrated on the screen. It might be photographs, before and after photographs. And there is no specific validation period generally defined. It needs to be appropriate to the nature of the concern. But before the activity is closed out, the team need to be confident, and sometimes the customer wants to be confident that the action really is effective. Having looked at the 4 phases of RCA, let's consider now some of the management aspects of RCA. Ideally, concerns will be communicated to the appropriate owner in the organisation and logged for tracking purposes. Communication with the relevant customer is usually necessary. In fact, some customers require their suppliers to use a specific problem-solving process and to apply specific timescales for updates and closure. ISO 9001 in section 10 tells us that the organisation shall evaluate the need for action to eliminate the cause of the non-conformity in order that it does not recur. Well, that's what we've been discussing already in this webinar. However, ISO 9001 adds the additional phrase, or occur elsewhere. And this is prompting the team to consider opportunities to export the countermeasure to similar processes and products so that it can be used in a preventive way to prevent similar issues occurring elsewhere in the future. And that means that the organisation get even more benefit from the current RCA activity. The systemic corrective action. The Toyota production system have contributed a couple of very key principles associated with this. Yokoten. This translates as across everywhere. Best practice sharing. It's prompting the organisation to recognise the lessons learnt from the RCA activity and share them with relevant areas of the organisation. Different work areas, different sites. Standardisation. Best practice being incorporated within the relevant processes and activities on a day-to-day basis. Continual improvement. Documented information is likely to be updated. such as process documents, planning documents, and risk analyses are likely to be updated. So these are systemic actions that go beyond simply solving the current problem. And these will help the organisation hopefully to reduce the number of problems which occur in the future. The benefits of using RCA: without RCA, often problems are solved by addressing the symptom. This usually means that the important underlying cause of the problem, the root cause, is not found. Therefore, the problem is likely to happen again. The purpose of RCA is to provide a standard approach to solving problems, with the aim that all problems within the organisation, within industry, are tackled in the same methodical way, avoiding trial and error. Problems are fixed permanently and prevented from recurring. The relevant processes and systems which allowed the concern to occur are reviewed and improved. So these are very useful benefits which are attainable. So how to take RCA forward? Some guidelines for effective implementation are shown on this slide. Establish a documented process for problem solving, which incorporates logging of concerns, monitoring of the activity, and a defined RCA methodology. Provide training and management support for personnel across the organisation. I've realised over the years that many personnel who are involved in problem solving activities are actually not clear as to what they're trying to achieve. They're not clear as to what a root cause is. How do they know whether they've got a root cause? What type of action is required? So this can hamper, this can be a barrier to effective implementation. Also, I've realised that problem solving activities are greatly enhanced if there is a sponsor, a champion assigned, management support. It may be the process owner, it may be a manager who is supporting the team, reviewing their activities, providing guidance as required. And that is a very key role, I believe, for success of problem solving. RCA gives, or we should give, visibility to problem solving activities. Organisations that I work with often have a designated area or a workspace which facilitates RCA activities. This might be a dedicated whiteboard or worksheets, perhaps in the work area or in a meeting room. It's important also to recognise achievements, and that helps to motivate and encourage other personnel to contribute to problem solving activities. This might be achieved during routine meetings, visual displays, etc. It's about explaining what activities are being carried out in the organisation and successes that have been achieved. Metrics can be very helpful to determine the effectiveness of problem solving. Number of RCA activities closed out on time, number of repeat concerns, number of improvements implemented, and ideally the future reduction of failure costs, cost of poor quality. Because if the Yockerton, the standardisation principles are incorporated, then that should help to reduce the number of future problems, which reduces the burden on the organisation's resources. Okay, worksheets and forms of various types are often used to facilitate problem-solving activities. The style of worksheet that I believe is particularly helpful is the large format, an example of which is visible on the screen. This gives visibility to all of the problem-solving stages from start to finish. And this helps the team to understand what has been covered so far, what are the next steps. They can see the whole problem at a glance, which is much easier than looking at individual forms or different files and folders on the computer. This style of worksheet may be printed on A3 paper. That often works quite well. I often see larger formats being used as well, and this helps enables photographs and other information to be added in. So it's very visual and it helps to facilitate the activity. So that brings us to the end of the slideshow presentation. I'm going to summarise now the webinar learning points. So during this webinar, we've looked at the 4 key phases of RCA. We've looked at some useful tools and techniques, but I will emphasise that I believe that RCA is largely about thinking. It's about teams pooling their expertise and knowledge and carrying out a sufficiently rigorous analysis by following some quite basic principles. Many problems can be solved by a simple approach. Tools and techniques are useful, but mainly it's about understanding, the team understanding what are they trying to achieve, where are they trying to get to. We've looked at the importance of effectively solving the issue by a permanent corrective action, and we've looked at managing RCA activities and how to take RCA forward. So that brings us to the end of the webinar, which I hope has been useful so far, but we haven't finished yet because reminder, first of all, that we can provide support to organisations at QMT. Please do feel free to visit our website or simply to contact us. And also, we have a question and answer session now, and we are hoping that there will be some questions, and I'm going to hand back to Jeff now to facilitate this session.
If you could just pop back one slide for me, John, please. Thanks. So you saw this slide right at the beginning. Those two links at the top, you can see FD 102 and 205 will take you to the CQI website, where you can find the syllabus associated with those two courses. And then underneath that, should you want to have more information, then you can follow those links, and they will provide you with more information about root cause analysis and also distance learning courses. That if that's because we live in a COVID world at the moment, unfortunately, and it does mean that you can do the learning safely. Using learn safely using the root cause analysis distance learning material that's there. If you want to recognise qualification, both of those courses are CQI recognised, and you get a qualification as long as you pass. There's an examination associated with those courses, or an assignment that's got to be done associated with those courses, and so if you pass that, then there's a qualification for it as well. The webinar itself is quite brief, as you probably gathered, and there's quite a few things in there that are talk techniques, like 5 whys is a talk technique, and there's a lot more information there. And again, it's brief. John has only got so much time. He's talking about comprehensive root cause analysis, and I know some of you, you might like to think about this as one of the questions. Some of you might want to know about concise root cause analysis as well, because not every root cause analysis issue is a major issue, so we might want to look at the significance of the issue and then decide whether we want to do a concise type of root cause analysis, or whether to do a more comprehensive one, 8D one, that John was referring to. So I'm going to stop there. If people want to know a little bit more about that, please ask the questions. And also during the question and answer session, Alex, I think, is going to has posed one of the questions, which is this difference between preventive and corrective action, and I'll do that through the question and answer session a little bit later on. Thanks very much, and thanks very much, John. Yeah, first class.
Okay, thanks.
Great. Well, thank you very much, John and Jeff. That was a really comprehensive walk through RCA. As Jeff has said, we've got a number of questions here. First up, I've asked John and Jeff to talk a little bit about preventative action versus corrective action. This is a point of that often comes up a little bit of confusion about the difference between the two. So Jeff, can we talk a little bit about preventative versus corrective action in this context?
Yes, people often talk about CAPA, yeah, and you may have heard this term CAPA, corrective action and preventive action. I've got a little bit of a problem. I'm probably going to tread on a few toes in a minute. John will correct me over this, I'm sure, if I've trod on too many toes. But I think it's a bit misleading, this term CAPA. Preventive action means stopping it from happening in the first place. So preventive action, stopping it from happening in the first place. Corrective action means making sure after it's happened that it never, ever, 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 ever happens again. So we've got these two choices to make. So let's just give you an example of what I mean by that. So if we take an electric fire, it's giving shocks and it's been out in the field, or perhaps a patient's escaped from a secure psychiatric unit. So we've got to do immediate action. The fire is giving electric shocks, so get all the fires back and all the rest of it, and that's all good. Or we identify the patient and hopefully put him back in a secure environment again, and that's all good. Then we have to do root cause analysis, and that's what John's been talking about up to now. And that means that we have to do root cause analysis of why the fire was like it was and why the patient was allowed to escape, and then we can make sure it never ever happens again. Hang on a minute, Jeff, what happened to preventive action and all that? Well, it doesn't exist. It can't exist because those two issues have occurred. And so preventive action is all those things we do preventing things going wrong in the first place. Corrective action is root cause analysis and all those good things as well. But hang on a minute, how do you prevent things going wrong in the first place? We can't prevent things. Oh, well, what about risk assessments? Can we do risk assessments? Oh yeah, there's that, but there's nothing else we could do for preventive. Well, what about doing audits or doing quality planning? Oh yeah, there's those things, but that's it. You couldn't do anything else more than that for preventing things. Well, there's a quality management system we've got in place. So you've got a quality management system that prevents things going wrong. But guess what? Do you know what? Quality management systems sometimes go wrong. And what we have to do then is do corrective action. So I've got a bit of a problem with CAPA. Sorry about that, everybody. But that's what I mean, is corrective action is done. Okay, a bit long-winded explanation. I don't know whether John wants to pick up any of that, but hopefully that worked.
Well, I will add I can't add much to what Jeff's just said, and I fully endorse that. I'm actually going to slightly complicate it a bit more, I'm afraid. But the reason for this is due to ISO 9000. And within the ISO 9000 standards, they refer to preventive action and corrective action, which Jeff has just explained, but they also use the term correction. And their definition of correction is it's an action to address a detected non-conformity. So there's no implication that it will prevent recurrence. That's corrective action. Correction is simply fixing the immediate problem. It's addressing the symptom. It's a remedial action. So, and the reason I've mentioned this is because I'm aware from my own experience that there is a lot of confusion in business organizations when they come across these three terms. So I just felt that it was worth adding that to Jeff's explanation.
Yeah. I think that's a very good point, and unsurprisingly, we've poked a little bit of a hornet's nest with this, which is one of the reasons I wanted to ask it, because it's perfectly understandable that there is often a perception that preventing an error occurring again is preventative action, but the key points there is happening again. So, when we're talking about preventative action, it's preventing it from happening in the first place. And I'm sure we could fill a whole 45 minutes and the rest of the week on different approaches to preventative action. So just to poke that a little bit further, can we talk a little bit about root cause analysis in the context of risk-based thinking and risk management, which again, not necessarily one and the same thing?
John, do you want to take it, or do you want me to just have a chat about that around that?
Well, I'll start off. It's interesting to note that the ISO 9001 standard I'm referring to the 2015 revision, has deleted the requirement for preventive action in favour of risk analysis. So that doesn't mean that preventive action is no longer required. It means that presumably the standard considers that it's part and parcel of risk analysis. However, other management standards that I'm involved with have retained preventive action. So they are expecting the organisation to identify risks and introduce actions which are proportional to the risk that's perceived, with the aim of reducing problems preventing problems from occurring later on. So I don't know if Jeff would like to add anything more to that.
Just a different, slightly different take on it. Something that John's only got so much time, and I'm sure he would have wanted to have talked to you about significance had he had enough time. And what Alex is hinting at is that the risks associated with an issue that's taken place, and so what we need to do associated with an incident that has taken place is to establish its significance. And we'd normally establish its significance on the basis of occurrence and severity. So in other words, occurrence, is it likely to reoccur again? Is it unlikely to reoccur again, etc., etc.? And there's a scale. And severity, is it going to kill somebody? Or is it just somebody's got a question they want answering and it's a bit of an issue? So from that, we can establish this risk assessment, if you like, of both likelihood of occurrence and severity. We can then determine what sort of risk root cause analysis we want to do. We've got the immediate, because Jeff, I've got audit discrepancies coming out my ears, mate. I've got loads of them. Yeah, and you want me to do a root cause analysis on all of them? You must be joking. I just haven't got the time. And nobody else has as well. And anyway, it's not necessary. They're just kind of some of these. It's kind of, not trivial, but not major. So, and that's what we mean by significance. And that's the risk assessment part, if you like, is to determine what do we do with it, this issue, because some we just ignore, but some we'll want to do a concise root cause analysis on, because I call it, quick and dirty root cause analysis, just because it's not. But some are really, really, really serious, and we really cannot have this major recall problem we've had on our hands. I don't want another injured person on my hands or customer on my hands. We must do a very comprehensive root cause analysis. So the risk-based element is making that judgment call associated with that. Okay, I don't know if John wants to pick up on that again, but anyway.
No, fine.
No, I think that's a really good summary, and one of the things that standards like 9001 are looking for is the application of that kind of thinking throughout the planning, the deployment, the implementation, and improvement of your management system. So it's something that has to be embedded throughout, where RCA may sometimes be a unique occurrence. Risk-based thinking is something that is just part of what we do day in, day out.
And that's something that John's been talking about RCA going forward as well. There's got to be a resource dimension to this, so it's got to be a management commitment dimension to this. There's got to be a resource dimension to this, and also there's a management of the RCA database as well. And don't underestimate the amount of work that's involved in doing this. So somebody's got to manage that. Somebody's got to log the things that go into that database. Somebody's got to allocate some of those things out to various people to take action on. And also in that system, we've got to sort out significance as well. So Alex has just been hinting about quality management systems. We need to be kind of clear within our quality management system. What's our policy with regard to RCA? Are we going to resource it? And moreover, what's the methodology that we're going to follow? Because 8D is great and fantastic, and we really do, need that some of the issues. But we also need a mechanism that takes on some of those lower issues as well. And we need to establish what that policy is from our quality management system. Hopefully, I know auditors are very keen these days on when they've raised certainly external auditors, when they raised a non-conformity, they always say, well, what's the root cause? Where's the analysis for the root cause for that particular issue that they raised? And so, again, some of those are quite small, but some are quite large, and we need to do a bit more analysis work on.
Yeah. Thanks, Jeff. I'm conscious of time, but I want to get through a couple more before we move on to parish notices, if we can. There's a point here about human error. Now, we all know the adage that that people don't fail, processes fail, and we can argue the relative merits of that position. But how do we cope with human error when it comes to root cause analysis?
Shall I take this one?
Yeah, it's fine, John.
Yeah. The key word which I hear a lot these days is robustness. And some clients that I work with take the view that if the process doesn't operate as it should, then it's a process problem. If somebody makes a mistake, the process design allowed that mistake to happen. Within the aerospace, they don't accept human error as being beyond the scope of RCA. In fact, in IS 9100, there is a formal requirement in clause 10.2.1 for human error to be addressed. And there are various definitions of the different types of human error. But in general, error proofing or poka-yoke devices are one possibility where the process is made more robust by introducing these methods and devices which prevent human error from occurring, or it might be that a weakness within a process can be resolved by changing the design of that process so that it's simply more robust to people's errors. Again, this brings us back to the Toyota production system. Going back to the 1960s, they challenged the conventional thinking that any of us can make a mistake because we're human, and we just have to accept that. Toyota didn't accept that, and they carried out a lot of research and developed the poka-yoke methodology around that problem, and they recognized different types of human error and recognized that often they can be addressed. So I don't know if Jeff would like to add anything to that.
Yeah, very often we talk about no blame culture, so that we can all feel free to make suggestions about how we can improve things, and so it's a no blame. We live in a no blame culture. If you had an air traffic control system that worked on the basis that they said that we live in a no blame culture in our air traffic control system, so that our air traffic controllers don't get blamed if they make mistakes, I don't think I want to fly in that area. I think I'll get a bit nervous about that. So they've turned that phrase into fair blame or just culture that says, we've got to own up to the mistakes that we've made, and we've got to own responsibilities for the mistakes we've made. But where does that leave human error then, in terms of, well, I think human error is just a little bit too trite. I often see that written down as part of the risk assessments that are done. It's down to human error, and at that point, I get kind of worried that people haven't really understood what the issues of this problem are. We do a little exercise. I call it. We've all seen Pointless on the television, where we identify breaking the human error down into 5 areas. And I say, what's the solution to each of those, like wrong identification, willful errors, I can't remember all the 5 at the moment, but there are another 3 areas as well. So willful, wrong identification, and other sorts of human errors. And I do a little exercise where I say to people, how can we solve that? How can we solve those problems? Because human error is very difficult to solve. Well, I've got hundreds of answers on how we solve those human error problems. So I think it's a little bit too easy to say human error. We need to break that down into its constituent parts. And there are a number of people that have broken that down. Duran, Crosby, Shingo, John just mentioned Poka-yoke as a means of breaking it down as well. So there are hundreds, thousands and thousands of means of resolving and stopping human errors, but we need a process in place that identifies what caused that human error, what the system caused, was it wrong identification, willful errors, whatever, and then we can move into trying to resolve it. So I'm not very keen. It sort of jars when I see the words human error written down as the cause.
I suspect we could have another full session on human error alone.
We'll do a session on Poka-yoke.
Why not? Why not? We are out of time, I'm afraid. So I am going to let everyone get back to work. Before I do so, just a couple of things. Please remember to fill in the feedback survey that will follow this webinar. We'd love to hear what you thought and flash up any areas for improvement, and tell us what you want to hear about next. Speaking of what's coming next, couple of events coming up. Remember the 5th of November, it's the CQI and NQA's Principles of Risk webinar. So please make sure that you sign up for that. Next on the horizon, we have the International Quality Awards. Tickets are selling fast, and although it's going to be an online event this year, I would encourage you to sign up for that as soon as possible. That is Wednesday, the 18th of November. One final reminder, you will have received an email about the CQI sponsored standards activity. This is a key piece of work shaping the CQI standards agenda going forward. So I'd urge you to take the time to complete that survey. Let us know what you think about the standards that matter to you in your role as quality and audit professionals. The only thing left for me to say is to thank John very much once again for an excellent presentation. Thank you, Jeff, also, both for your contributions and for handling the questions so diligently and thoroughly. Always a pleasure to have QMC on these sessions, and we'll look forward to seeing you again. Thank you everyone for attending, and sorry for keeping you a couple of minutes over time, but I'll look forward to seeing you at the next CQI webinar. Thanks everyone.
Thank you. Thank you.
Thank you.